Hey everybody, happy Tuesday to you. Today we are going to be taking a look at the exact value of trig ratios on the unit circle. So a quick reminder that the horizontal component, or the x value on the unit circle, is the value of cosine. Sine is the value of the vertical, or the y component. So if I've got angles like the ones that I've got shown here, 90, 180, 270, 360, where they are either straight up or straight down, straight left, straight right, you're going to have a lot of zeros and ones because those are our coordinates. Sine of 90 degrees, well, 90 degrees is a rotation from standard position pointing straight up. And at that point, at that 90-degree angle, the coordinates of that point are 0, 1. And since sine is the y value, sine is 1, plain and simple. Sine is the y value. Cosine of 90 degrees would be 0 because that's the x-coordinate. For 270 degrees, we're rotating all the way around to straight down. 270 degrees is straight down. The coordinates at this point are 0, -1. So the sine value would be -1. That's the y value, but the cosine value is the x. That is 0. I'm not going to worry about tangent today. We're going to focus on tangent on Thursday, but we can talk about secant because that is just the reciprocal of cosine. So if we know cosine, we should be able to figure out secant. Now, 360 degrees, that's a full rotation all the way around to get to that point. And so if I've got a 360 degree rotation, that means I'm in my same initial position. The coordinates of that point are 1, 0. And so the value of cosine, the x-coordinate, would be 1. This would be the reciprocal of that, but 1 divided by 1 is just 1. So secant is 1. By the way, sine would be 0, which means cosecant would not exist because the reciprocal of 0 does not exist. It's infinitely large, but more on that later. So that's if it's straight up, straight down, straight left, straight right, lots of zeros and ones. But we got to take a look at how to do a lot of other angles. So what I'm going to take you through right now is how I use the unit circle. There are lots of ways of doing this. If you asked all of the teachers at Burnsville High School, we'd probably have about 5 different ways of doing this. If this doesn't make sense to you, I will suggest go on YouTube and see if there's another way of finding angles on the unit circle that makes more sense to you. I'm not saying that this is how you have to do it, but I am going to show you how I do things like cosine of 210 degrees. So we're going to take a look at cosine of 210 degrees. Step 1 is figure out where are you on the unit circle. So we're starting at 0 degrees, pointing straight in the positive x direction. Rotate by 90 degrees, 180 degrees, almost there. 210 degrees is just 30 degrees more than that. And so we've got an angle that's down here. I've got a 30, 60, 90 triangle down here because I'm 30 degrees past 210. Now, if I'm asking you to do exact values, the triangle that we form, the triangle that I formed here, that we form in whatever quadrant, it's going to have to be one of 3 types of triangles. I'll refer to this as the tall, skinny 30, 60, 90 triangle. This is the short, wide 30, 60, 90 triangle. And then this one, if it's as tall as it is wide, it's an isosceles right triangle, the 45, 45, 90 triangle. Reminder from before break, we figured this out by taking a look at half of a square at an isosceles right triangle. We took a look at half of an isosceles triangle, half of an equilateral triangle to get the 30, 60, 90 triangle. You can check the notes from that. But what we learned is that the short side of these 30, 60, 90 triangles on the unit circle have a length of 1/2, and that the long side is the square root of 3/2. This comes from the Pythagorean theorem. This comes from geometry. This comes from all kinds of stuff that we did before the extended break from school that we just got done with. So short side of a 30, 60, 90, 1/2, long leg of a 30, 60, 90, root 3/2, no matter whether it's tall and skinny or short and wide. And then for the 45, 45, 90 triangle, the 2 sides are the same. And again, from the Pythagorean theorem, from geometry, from the way that math works, both of these end up being the same thing. These are both the square root of 2 over 2. So vertical and horizontal are both the same thing. On the unit circle, if I ask you for exact values, it's going to have to be angles like this: 30, 45, 60, 90, 120, 135, 150, all of these angles. These are the ones that are going to give us either the tall and skinny 30, 60, 90 triangle, or the isosceles right triangle, or the short and wide 30, 60, 90 triangle. But any one of these is going to give us those shapes for triangles. I'll finish these up, but if I try to do this efficiently, it ends up being sloppy. I'll try to do this so you can see the triangles that I'm talking about. So anyway, there we go. These are the types of angles that we're going to be taking a look at. A reminder that the cosine value is the horizontal, the x component, the sine is the vertical, or the y. So back to 210 degrees, we're looking at cosine of 210 degrees. So once I figure out where I am, I've got the 30, 60, 90 triangle that's over here. Cosine is the x component, so I'm looking at that length right there. That is the long leg of this 30, 60, 90 triangle. So it's the square root of 3 over 2, but it is to the left. So we're going to call that negative square root of 3 over 2. And that is my answer for cosine of 210 degrees. As long as we're here, let's talk about sine. Sine of 210 degrees, same triangle, same setup, but now I'm looking at the vertical component. Vertical component of this is the short side of the 30, 60, 90 triangle, so it's a half, but because it's down, our answer is going to be negative 1/2. Sine of 210 degrees is negative 1/2. All right. And then if we've got sine and cosine, then we can also do secant and cosecant because they're just the reciprocals. If cosine was negative root 3 over 2, then secant will be the reciprocal of that, negative 2 over root 3. But we don't want to have a radical in the denominator, so we'll rationalize that like we did um, in a previous chapter. I'll multiply by root 3 over root 3. We end up with an answer of negative 2 times the square root of 3 over 3. And you'll be seeing a lot of these same numbers again and again and again. If you want to start switching straight from this to this, I understand. This is a process that a lot of you are going to just memorize and get to be really good at. Cosecant, the sine value was negative 1/2, and so the reciprocal of that is negative 2, and that does not require any simplification. So there we go. That's how we do it. All I would like to do with the rest of this video is to take you through a few examples. Just to show you, looks like I've got 8 of them picked out, which sounds like a lot because that took a long time, but each of these should go fairly quickly. So hopefully once you've seen a few of these, you'll see how quick it is, how easy it is, and you'll be able to get through the homework assignment relatively quickly. So here I go. When I'm doing cosine of 135 degrees, I'm visualizing a unit circle. Maybe you just want to have one drawn out for yourself. I'm being kind of sloppy, but it's okay. I don't have to be perfect on this one. I just have to figure out what type of a triangle. 135 degrees, that puts us at 45 degrees less than 180 degrees. So there's my hypotenuse. This is a 45, 45, 90 triangle because I'm 45 less than 180 degrees, which means my cosine value, this horizontal component, is square root of 2 over 2. It's to the left, so it's negative square root of 2 over 2. All right. And I'm going to go through these quickly. You'll have to go back and rewind if you want to see them repeated, but I also don't want my video to get to be too long. Sine of 300 degrees. First, we figure out where 300 degrees is on my unit circle. So 270, let's see, 300 degrees would be 60 degrees less than 360. So we're looking at the tall, skinny triangle where I've got 60 degrees less than 360 degrees. Here's my triangle. Sine is the vertical component, which means I'm looking at the long leg of this 30, 60, 90 triangle. So it's the square root of 3 over 2, but it is down. So I'm going to go with negative square root of 3 over 2. All right, next example I want to take a look at is secant of 315 degrees. So first we'll figure out what the cosine value is. And once I've got the cosine, I'll just take the reciprocal of that. We'll see what that looks like. So 315 degrees, we're over here. We're 45 degrees less than 360, which means we're looking at the 45, 45, 90 triangle. So the cosine value, the one that we care about, that's this one over here. That would be the square root of 2 over 2 because it's a 45, 45, 90 triangle. My secant value will be the reciprocal, so I'll flip that upside down, 2 over the square root of 2, and then rationalize the denominator to get my simplified answer, which will be 2 times the square root of 2 divided by 2. And of course, 2 divided by 2 will cancel out. Excuse my sloppiness here. But 2 over root 2 cancels out, and my answer is just positive square root of 2. Next example. Oh, here's another reciprocal relationship. So 390 degrees. First, figure out where we are on the unit circle. 360 degrees takes us all the way around. And let's see, 360 plus an extra 30. So we're 30 degrees more than 360. So I've got my 30-degree angle there. I've got a 30, 60, 90 triangle. Cosecant is the reciprocal of sine. Sine is the vertical component over here. Let's see, the vertical side, the short leg of this 30, 60, 90 triangle is 1/2. It's positive because it's up. And then cosecant is the reciprocal of 1/2. And so that is 2. Halfway done with the examples, just 4 more to go. Cosine of 150 degrees. Let's see what this one looks like. And again, I am not being really careful. I'm not measuring with the protractor. I'm just trying to figure out, is it the tall and skinny? Is it the short and wide? Or is it halfway in between? Is it the 45 degrees? So for this one, 150 degrees, I am 30 degrees less than 180. So I've got the short, wide triangle, just a 30-degree angle over here. Cosine is the horizontal component. Notice that's the same distance that I drew for the 210-degree angle that was our first example. Negative because it's to the left, square root of 3 over 2 because it is the long side of that 30, 60, 90 triangle. Next example, similar, except instead of positive 150 degrees, we're going to go negative 150 degrees. What a lumpy circle we've got there. Let's see, negative 150 degrees, negative 150, negative 180. We're just 30 degrees less than negative 180, or I guess 30 degrees more than negative 180, but that leaves us with that 30, 60, 90 triangle, the short, wide 30, 60, 90 triangle. Cosecant's the reciprocal of sine. So the sine value, sine of 150, excuse me, negative 150 degrees, that is the vertical component. That would be negative 1/2. And so cosecant is the reciprocal of that. We've got negative 2. And then 2 more for us to take a look at. Another reciprocal, another negative for us to deal with. Negative 60 degrees means we rotate by negative 60. We're rotating in the clockwise direction. We give ourselves the tall and skinny 30, 60, 90 triangle because I've got my 60-degree angle there. Let's see, secant is the reciprocal of cosine. Cosine is the x value. My x value is 1/2. That's my cosine value. But this is asking for secant, so it's the reciprocal of negative 1/2, excuse me, positive 1/2. And that is positive 2. And then last example for us to take a look at today, sine of negative 480 degrees. So we're past 360 degrees. My rotation all the way around, negative 90, negative 180, negative 270, negative 360. Let's see, 90 degrees more than that. We're at negative 450. And then I've got just 30 degrees more or less than that negative 450, which means we've got our tall, skinny triangle. I've got a 60-degree angle here. You could think of it as a 30-degree angle there, but that gives me the 60 degree as my reference angle. Sine is the vertical component, so I'm just looking at this distance right here. That's the long side of the 30, 60, 90 triangle. So it's the square root of 3 over 2. It is negative because it's down, and there we go. Again, go ahead and rewind and take a look at these examples again. The homework you're going to have um, due tomorrow at midnight is problems like these. Hopefully, you'll start to get comfortable with this process. The homework is due tomorrow at midnight. I know we don't technically have class tomorrow. I thought about making it due tonight, but why not? I'll make it due Wednesday because you'll have a little bit extra time. On Thursday, it'll be the same idea, but we will add on tangent and cotangent values. So if you've got questions about this, certainly let me know and I'll try to get things cleared up. But as long as we're okay with what we did today, tangent and cotangent should be a pretty easy addition. As always, if you have questions, post them on the Google Hangout. I don't think I've gotten too many comments or questions from this class. Or if you've got a better idea, if there's a different forum that I should be using for this, let me know what that should be. Otherwise, email always works as well. So that's it for today. I will see you guys virtually on Thursday. Have a great day. Bye-bye.